We can have a couple of special cases that come up occasionally in applications and science. So we have definitions and special names for these types of log functions. The first one is ln. It's called the natural logarithm, and it's just a log with a base of e. And the second one is called the common log, and it's written just log. It's the log function with a base of 10. They have all the same properties and they work the same as any other base. They just have special names, and you will also notice on your calculator you probably have an ln button and a log button, where you may not have a log with a base A button. So these come up occasionally, and we just need to know what they mean. We'll treat them the same as we would any other log function. So if we had to find a domain of an ln of x, we would treat that as just what keeps the inside parentheses positive. All right, so our last topic of this section is solving log equations. We're going to work it similarly to how we solved exponential equations. This is our plan. If we can get a log base A on the left and a log base A on the right, and we have some stuff inside, then we could just get to the inside m and n and set them equal to each other. So, for example, if log base 3 of x plus 4 is equal to log base 3 of x minus x, let's make that just 12. Since we have the left and the right balanced, they have the same base, there's one log on the left, one log on the right, we can go to our x plus 4 equals 12 step, and then solve. Subtract 4, x equals 8. What we have to be careful about is that what we have is in the domain of the log function. So is it okay to put 8 back in to the original problem? 8 plus 4 is 12. 12 works out, no problem. Another type of exponential log type equation that we might see is if we don't have two logs, but we just have one log function. So if we've got something like log base 3 of 4x minus 7 is equal to 2. If we have this situation, then we can change the form from logarithmic form to exponential form. So we're going to use the definition of how to switch back and forth. 3 squared is equal to, so 3 squared is equal to 4x minus 7. And now we can work that problem. 3 squared is 9 equals 4x minus 7. Add 7 to both sides. That gives us a 16 equals 4x. Divide both sides by 4, gives us 4 is equal to x. Is that okay? Is it okay if x equals 4? Does that stay positive inside that? 4 times 4 is 16 minus 7 is a positive number, so that's okay, and it works out. How about this next one? Log base x of 64 is 2. Well, there's only one log in this problem, and the x that we're solving for is in the base. So let's again change it to exponential form. X to the 2 power is 64. At this point, we can take the square root of both sides, and x is the square root of 64 now, Normally we'd have to do a plus or minus square root 64, and that would give us a plus or minus 8. However, the base of the logarithm has to be positive. So we can only use the positive part. X is equal to 8. Let's do another one. If we have e to the 2x is equal to 5, this doesn't look like a logarithm problem. This looks like an exponential problem. But if we try to use the techniques of solving exponentials, you remember we have to get the bases to match. I don't see any way that I can get 5 to look like e to the power. So I'm going to change this from exponential form to logarithmic form. This becomes log base e of 5 is 2x. Now log base e, that sounds like the natural log. So I'm going to write it as the ln of 5 is equal to 2x. Now, to solve this, I can divide both sides by 2. So the ln of 5 divided by 2 is equal to x. And that is our solution. That's an exact solution. If we wanted to get an estimate of that solution, we can put it into our calculator. Depending on what kind of calculator you have, you may have to put it in differently. But I put in the ln parentheses 5 parentheses divided by 2, and I get 0.8074 and some more decimal places for x. You want to be sure that you use parentheses correctly, or else you will end up with the wrong number. This 2 does not interact with that 5 at all, because that 5 is in the parentheses. So order of operations say you have to do what the log function is. Well, that is, put it in your calculator, ln of 5, find that value, and then divide by 2.